So we are dealing with the third problem in this segment. The third problem in this segment is problem number 5.273. This problem is asking find the photoelectric threshold for zinc and the maximum velocity of photoelectrons liberated from its surface by electromagnetic radiation with a wavelength of 250 nanometer. So this is the information that is provided in the question. If you check the book properly, over there it is mentioned that work function for zinc is equal to 3.74 electron volt. So the work function which is supposed to be mentioned in the problem is mentioned in the appendix portion of the book. So over here, if we come back to the problem is asking us for the calculation of work function. So work function corresponds to the minimum amount of frequency or wavelength at which, for wavelength we say maximum wavelength for which the electron emission starts. So we can say that work function or phi over here can be written as Hc by lambda threshold. So again, if we decrease the value of lambda, energy will increase. So that is why we say we calculate the maximum value of wavelength as threshold wavelength. So over here, if we calculate lambda threshold, we can write it as Hc by phi. So if phi is measured in electron volt, then we can write it as 1240 by energy in electron volt, then the answer will be in nanometer. So on solving, we obtain this one as 331.5 nanometer. So as the answer is given to us in three significant figures, we are putting answer as 332 nanometer. So this is the answer to first part of this problem. Now it is asking us to calculate the velocity of the photoelectrons liberated from the surface. So over here we can say that for photoelectric effect, the maximum kinetic energy emitted for the photoelectron is equal to incident energy minus work function. So we subtract the value of work function from the incident energy. The incident energy in this problem corresponds to 250 nanometer. So over here, kinetic energy maximum, that is half m v maximum squared, is equal to 1240 by 250 nanometer. So this value will be in electron volt minus 3.74. So this value will be in electron volt. So on solving, we obtain this as 1.22 electron volt, and over here, if we solve, we can write it as half of 9.1 into 10 to the power minus 31 kg V maximum square is equal to 1.22 into 1.6 into 10 to the power minus 19 joule. So we can calculate the maximum speed which is possible. 2 into 1.22 into 1.6 10 to the power minus 19 divided by 9.1 into 10 to the power minus 31 is square root. So the value will be in meter per second, and on solving this, we obtain the value 6.6 times 10 to the power 5 meter per second. So this is the answer to this problem that we have.